we're going to start this video by comparing some fractions. So looking at the fraction 5/8 and the fraction 7/12, we want to know which one is bigger. And we can kind of draw these out, but 5/8, if I kind of estimate 5/8, maybe somewhere around there. If I compare 7/12, they're fairly close together, so it's pretty hard to figure out which one is going to be bigger. So we need some sort of method to be able to compare these fractions a little bit more accurately. And we want to show these with equivalent denominators. And so we need a common denominator for these two fractions. We're going to express this as an equivalent fraction with a different denominator, and this is equivalent fraction with a different denominator. And those two denominators should be the same. If we do that, we now can then compare the same size fraction pieces. So in this case here, what would be the denominator that we should use to compare these two fractions? So between 8 and 12, we should use the common denominator of 24. So to get a common denominator, or to get an equivalent fraction with the denominator 24, we need to multiply this one by 3. And keeping the fraction or ratio balanced, we need to multiply the top by 3. And again, I want you to show these factors. And so this equivalent fraction can be expressed as 15/24. So we want 24 here as well. So to get a denominator 24, we're going to multiply the bottom of this one by 2. And to keep the ratio the same, or the fraction the same, we need to multiply the top by 2. And then we can now compare 5/8 and 7/12 a little bit more with a common size piece, which allows us to then establish that which one's going to be bigger. So if I have 15 of these 24th pieces and 14 of these 24th pieces, we can see that the 5/8 or 15/24 is going to be bigger than 7/12 or 14/24. So we can compare these sets of fractions the same way. So to compare these two fractions, we have 1/4 fractions and 1/8 fractions. What we can do is convert this one into a 1/8 fraction. To do that, we multiply the bottom by 2 to get 8. We can multiply the top by 2 to get 6. And so 3/4 is equivalent to 6/8. Well, we know that 6/8 is going to be more, because there's more pieces here, than 5/8. Here we can get a common size piece of 15 by multiplying the bottom by 3, the top by 3. We get 12/15, and we're going to get 3/15. And we can see that 12/15 is going to be much greater. We could also do something slightly different here. So instead of multiplying to get a common denominator, we can simplify this fraction. Since we have a common factor of 5, I can divide by 3, and I can see that 1/5 is definitely smaller than 4/5. Okay, we get a common denominator by dividing, but typically it's easier to multiply to get a common denominator. So this one here, I can multiply the bottom by 7, and that's going to give me a denominator 28. If I multiply the denominator here by 4, I'm going to get the same denominator, because 4 times 7 is the same as 7 times 4. I just have to remember to balance the ratios. So I end up here with 21 over 28. Here I end up with 20 over 28. This one is going to be bigger, so we know that 3/4 is bigger than 5/7. So same thing can be done here. We can multiply this one by 8 and this one by 3, because we know that 3 times 8 is the same as 8 times 3. Make sure we balance the fraction off. We have an equivalent fraction of 16 over 24. It's equivalent to 3/2. Here we know that 15 over 24 is equivalent to 5/8. So 16 over 24 is greater than 15 over 24. Now there is a quick way to do this, so we should really be getting common denominators, but if we know that multiplying the bottom by 8 here and the bottom here by 3 over on the right hand side, and we're going to do the same to the top, essentially what we can do is we know that the bottoms are going to be equivalent, so we can kind of focus on the tops. And if we are confident that we're getting a common denominator by doing this, we can actually just compare this product with this product. So 16 is greater than 15, and we can do a quick estimate of our fractions this way. Now, this is not what we're doing necessarily because we want a common denominator, but this is a quick way we can compare two fractions.